Thank you for joining us on this Friday morning of Space Vision 2015. Thanks to William Conrad for kicking off Friday programming, and thank you for joining us for the Life and Living on the Red Planet program. I'm joined today by three guests who have a wide range of interests and expertise in our Martian neighbors. We have Bruce Mackenzie, who is currently the founder and executive director of the Mars Foundation. His writings and concepts on brick-type habitats for Martian settlement has helped shape science and science fiction alike with authors such as Dr. Robert Zubrin and Kim Stanley Robinson. We also have Jim Bell, who is the principal investigator of the Mackenzie on Mars 2020, deputy principal investigator for Mastcam on the Curiosity, as well as being involved on many previous missions to Mars, including Pathfinder, Spirit and Opportunity, the Mars Odyssey Orbiter, and the Mars Reconnaissance Orbiter. He's probably seen more of the Martian surface than any of us can ever imagine. He's the current president of the Planetary Society and a professor at Arizona State University in the School of Earth and Space Exploration. And we are also finally joined by Paul Withers, who is an assistant professor of astronomy right here at Boston University, whose research focuses on the upper atmosphere and ionosphere of other planets using data to develop theoretical models to discover how solar flux, a neutral atmosphere, magnetic fields, and an ionosphere interact under the unique conditions of each planet. Now, to get us started, I'm going to ask us some questions to kind of start discussing things, and then at the end, we're going to have some time for questions from the audience. So if you have any interest, where are the microphones? We have some microphones for you guys to get up and ask our questions. So I guess first, let's talk about some of the discoveries that have been recently made for Mars. You know, the discovery that we recently had an atmosphere there that got blown away by the solar winds. The salty, briny water underneath the surface of the dirt. How did these change your views on if life had ever lived there, and how did they change your views if life could ever live there, such as humans?
Just throwing it open.
Yeah.
All right, great, thank you. Thanks for the invitation to participate. Also, just echo what Will said. I know ASU hosted this conference 2 years ago, and so I know what went into making it happen, so kudos to all the organizers. Great thing you guys are doing. So yeah, let's talk about some of the recent discoveries. I assume you can tell us more about Nathan and the atmosphere.
Absolutely.
So I'll talk about the surface a little bit, and maybe start with because I can't resist, I'm a professor, so start with a teachable moment, right? We didn't discover liquid water on Mars. We indirectly found evidence for liquid water on Mars currently. And that's an important distinction to make, right? We haven't seen drip, 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 pour, and flow. Haven't seen that actually happen on Mars. What was announced recently was the discovery of some salts that were left behind when presumably liquid water escaped from the subsurface, not the surface, the subsurface, to flow across the surface for a brief period of time. And that's really cool, right? It's really cool to think that that there is most likely liquid water in the subsurface accessible to future human explorers, which would be amazing. But I will be honest and tell you that my friends in astrobiology, they're a little worried about this discovery, actually, because those salts that were left behind, a certain kind of material like perchlorate, is really, really toxic to life as we know it. And so this salty brine was not sodium chloride. It was some kind of a bizarre chemical mix of different kinds of chlorates and oxygen, and very oxidizing. And little buggies like we know them on the Earth would not like that water at all. And so there's some argument that that might actually be a setback for thinking about life as we know it being on Mars. Now, it turns out, results from rovers on the surface have painted very different stories about the early water. Opportunity rover back in 2004. Yeah. Still going strong. It'll be 12 years in January. Opportunity is still going strong. Found, again, indirect evidence through the mineralogy of liquid water existing in the subsurface and probably the surface. Very acidic groundwater. Lots of evidence of sulfate salts dissolved in that water, which would have given it a low pH. Also potentially troublesome from the astrobiology perspective. But of course, we don't know really on the Earth whether life formed in acidic water or salty water or neutral water or whatever. So that's potentially problematic, but still evidence. And in Curiosity, most recently, discovering evidence of all these clay mineral deposits, which require a relatively neutral kind of freshwater environment to form the specific kinds of materials that have been detected. Maybe much better news to see that kind of environment, place where there was a groundwater, standing water, flowing liquid water on the surface, again, indirectly, based on the geology and the mineralogy. And so what these discoveries are telling us is that Mars is not just sort of monoplanetic, right? It's not just one kind of environment. And maybe we shouldn't be surprised by that, because our own planet has all kinds of different environments. Life on our planet fills all kinds of different niches of temperature, of salinity, of acidity. And so maybe we shouldn't be surprised that Mars shows those kinds of environments as well. The good news is that there is liquid water there in the subsurface. We've known that there's water in the atmosphere for a long time. We'll hear more about that in a minute. We've known that there's ice in the poles and in the subsurface at high latitudes. And there's likely a groundwater system there as well. And it's when we go find it, when we tap into it, it's not clear that we'll be able to drink it. But maybe if we can't drink it here, maybe we should go over there and find that different kind of environment. And so I think that's the real news from these discoveries.
So the present day ideas of liquid water on Mars seem to be that there are fairly small quantities of liquid water around in the most promising interpretation of things. Maybe there's more that we can't see, not so far beneath the surface of Mars, but it seems like it's limited amounts of liquid water, maybe for limited periods of time there. Then if you look at the mineralogical and geological evidence that Jim was talking about for hundreds of millions, billions of years ago, you shift to a paradigm where there seems to have been a lot more liquid water involved for extended periods of time. And one of the research questions that I'm interested in and that the MAVEN spacecraft is trying to explore is, so where did all the water go to? Did all the liquid water that used to be, that we infer, used to be present on the surface of Mars, did that just escape away into space, or did it somehow drain into the subsurface of Mars, get absorbed into the rocks and mineralogy of the subsurface in some way or another? One of the goals that the MAVEN spacecraft is trying to explore is to see just how much water is escaping, evaporating out of the top of the atmosphere today, and then boldly extrapolate 2 years of observations over 4.5 billion years of solar system history, and try to piece together what the ancient Martian water inventory was like there. The first results that came out in Nature a week or so ago, those don't really answer that question yet. We're simply not there yet in having an accurate understanding of either present-day escape rates or how those escape processes might have evolved over solar system history to produce the planet we see today. Hopefully, if you come back to Boston in a few years' time, we might have more concrete ideas on how much water has been escaping from Mars, and thereby a better sense of what the past inventories were. But MAVEN at the moment is just in the first results stage. It hasn't had an opportunity to really synthesize together a comprehensive picture of the escape of water from Mars. But soon.
Yes. Okay, so we've known since the first flybys that there were riverbeds, ancient riverbeds on Mars. So in ancient geologic time, Mars might have been amenable to life. So finding evidence of flowing water recently really hasn't changed my opinion on the chance of life having been there in the past. But it means that the life might possibly be still active. But we don't see any evidence on a global scale of active life. That is, for example, on Earth, there is oxygen in the air, and that's chemically, it's not in chemical equilibrium. But the Mars atmosphere appears to be more or less in chemical equilibrium. So there isn't a really thriving biosphere there that would throw the atmosphere off. So we're pretty sure that if there's existing life, it's not very active. As far as whether we can live on Mars, how does it change my opinion? It actually complicates things a little bit, because every time, so assuming we have a human settlement on Mars, the scientists might want to be right near the most interesting thing, right near where there might be flowing water. But every time you open an airlock, there's a very, you're going to be letting bacteria out. And if there's any chance of Earth life getting a hold in those, liquid flows, it'll be much harder to study and look for past life. So the complication is you might actually want your human base away from the most interesting area, and then send sterilized rovers in there and control them remotely. And that's a complication that's kind of obnoxious. That's all.
There is actually a NASA official whose job title is Planetary Protection Officer, whose job it is to worry about protecting Mars and other objects in the solar system against contamination from Earth-like bacteria.
I think talking about some of these in situ resources, if Bruce would like to come and talk really quickly about future living with your slides.
Yeah, I didn't know what order. So my main interest is how will we live there in the future, and how will we build there? And this is normally, I've got slides from 2 different half-hour shows. I'm going to go through them really fast. Don't bother looking at the words, because these slides were taken from other things. Okay, so Mars Foundation. Why Mars? Mars is the best place to grow food initially. It has nitrogen and carbon and water and sunlight all in the same spot. So if you're gonna make a permanent settlement in one spot, that's the place to do it. You don't have to keep resupplying from Earth. It bugs me that people talk about round-trip exploratory missions, because in some ways permanent settlement might be about the same cost and about the same effort. But settlement and exploration really are different from each other. If you want to settle, you want to manufacture as soon as possible. You'll probably be doing that indoors. You don't need to do a lot of EVA. And the key is manufacturing and agriculture. And talk about settlers, not crew members. This is a fabrication lab, or a makerspace fab lab that we would like to send to Mars. And this slide shows a methane generator that high school kids make. You can take the Martian air, carbon dioxide, electrolyze the water from the permafrost, feed it into this thing, and it will make methane. And then methane and other hydrocarbons can be used to make various polymers. You can bootstrap the machines. Here is a homemade laser cutter on the bottom and a homemade router on the top. So you take a few, makerspace type tools in Mars and you start making more. I mentioned agriculture. That's a key difference. As soon as we can get agriculture and manufacturing there, then it can take off. We might start with just 2 people. Their job is just to keep the machines running. Not to explore. After you get a lot of machines and a lot of food stockpiled, then a bunch of scientists can go and they can spend a lot of time on Mars. Here's one of our first design. This was for 12 people, and we estimated that building a permanent base that would keep growing would be about the same launch cost as 3 round-trip missions. And we're trying to figure out what sequence would be the minimal cost to get this thing bootstrapped. Here's what it might look like. You bring in dirt in the far left, make it into fiberglass, make polyester from the air, and make big fiberglass cylinders, join them together, and you're building a base. This could be a science base and a manufacturing base. Close-up view of the cylinders and where you make them. Novel construction techniques. If you've read Kim Stanley Robinson, the underhill structure was my design, and it might look something like this. So basically the Romans could have built on Mars. You don't need really high-tech aerospace on Mars. The Mars Foundation has a 3D printer at Mars Habitat. It's not our habitat. In Hawaii, we're looking for demos to run there. So the summary is we can get a lot more science done on Mars if we have people there permanently, and that's a long-range goal to expand beyond the Earth anyway. Once you've expanded to Mars, the lessons learned there can make it easier to live on the Moon and among the asteroids, and the key is growing food and manufacturing. So that's the summary. 1 hour.
Yes, I'll chime in. That's wonderful and optimistic, enthusiastic. I tend to be a pragmatist and think about what can we do, soon. And so I don't have any slides, but tomorrow night I'll be talking at the banquet about some of the infrastructure that's happening now and the ways that that we can make some of that start to come true in your career lifetimes. Hopefully mine too. For as long as I've been, as long as I can remember, getting people to Mars has always been like 30 years away. And I grew up watching them drive cars on the moon. Wow, that's really cool. We should go to Mars. Yeah, just 30 years, we're gonna be there. Get to high school and space shuttles, like, yeah, just 30 years, we're gonna get to Mars. And now I think that we're maybe 20 years, 25 years away. I think that there are realistic paths to start doing this, not this yet, but to start doing this kind of stuff within the sort of overarching infrastructure of what NASA is trying to build and do. So I'll talk more about this tomorrow night at the banquet. Other space agencies, other companies may leapfrog over what NASA is planning, but as Will pointed out, it really is the nature of governments to invest large amounts of money in space exploration because the taxpayers are not investors, they're not stockholders, they're not expecting a monetary return necessarily. They're often, turns out, perfectly happy with intangible return like national pride, like education, like inspiration for young people, things like that. And so governments are sort of the only companies that can put that kind of money into it. So I'll talk about sort of NASA's plans and a recent study that Planetary Society participated in that shows that there really is a tangible, actual path to people getting to the surface to start this enthusiastic process in the 2030s. So I'll just maybe give a teaser for my talk tomorrow night.
Jim, I think there'd be a lot more money available if the general public can look down the future and say, we will be able to live in space sooner than what they're currently being told. So I think we need money to get into space, and more money will be available if the average person can see someone like them living in space indefinitely.
Totally agree.
So how do you think things like The Martian and Interstellar and other popular cultural films are bringing space to mind and showing the public that it's optimistic, it's not scary like Gravity, but it can actually succeed? Do you think that's affecting their opinion at all?
I'm not sure it's going to have any tremendous long-term effects because space movies have been around in one flavour or another for longer than I've been alive. 2001: A Space Odyssey was, I believe, filmed before astronauts set foot on the moon, and that's still a tremendous touchstone for people's ideas of what exploring in space, living in space ought to be. And so the recent flurry of space exploration movies, of Mars exploration movies, I don't think they'll have a tremendous long-term impact. They're cool.
I must respectfully disagree. I love The Martian. It's just, okay, so we need to have like a Mystery Science Theater 3000 thing, The Martian. You get like a whole bunch of Mars nerds saying, oh, that's wrong, no, that's wrong. You know, the sandstorm at the beginning, oh my God, that could never happen on Mars. Never, right? And there's all kinds of stuff like, you know, the mast for the camera. There's like 7 people in the world who know that's not the right mast for the Pathfinder camera, you know? Okay, we can nitpick it to death. Okay, we can absolutely nitpick it to death. But millions of people, more than we will ever reach with our journal articles, are seeing what I think is, at least in my lifetime, the most accurate representation of what it will be like to send people to Mars. It is not completely accurate, but it's, you know, not ridiculously stupid Hollywood inaccurate. It's like just a little bit inaccurate. But a lot of the technologies, a lot of the infrastructure they talk about, a lot of the methodology and the celestial mechanics and that kind of stuff, you know, JPL doesn't really look like that in the movie, okay? But a lot of it is based on, you know, reality and a reasonable extrapolation of today into, you know, 15, 20 years into the future. And, you know, my family's gone and seen it, and, you know, parents, they're not in the space business, but they're like, well, you know, that seemed really realistic. I was like, yeah, we can actually do that. We could actually do that on that time scale. And I think that is resonating with people in a way that maybe, you know, 2001 didn't, or Interstellar doesn't. You know, it's so futuristic, and, you know, even Star Trek and Star Wars, right? You need these technologies, you need warp speed, you need phasers, you need lightsabers, you know. None of that exists, and you can't even extrapolate today's technology to figure out how to make a warp engine, right? But The Martian is like presenting a reality that could happen, and so I think it's making a huge difference, and I think it's going to be a very inspirational turning point for a lot of people.
Okay, I think in general space movies are getting more realistic. When I was a kid, the movies often relied on things that violated the laws of physics really badly. Like one actor can visit multiple star systems, you know, sort of by magic or warp speed within one lifetime, and that we don't know how to do that. We don't know if it would ever be possible. Let me throw out 2 things that you guys can pass on about these movies when other people are talking to you. So in the movie Gravity, there's the Kessel effect, where there's space debris that hits rockets that causes more space debris. It all gets broken up. Yes, the Kessel effect can happen. It may have already started happening, but it's not going to be this wave of shiny meteor, you know, glowing objects hitting you all at once. It's going to be 1 or 2 at a time, and it'll take years for the Kessel effect to happen, and you won't get hit by this giant barrage of space debris all at once. So yes, it can kill you, it can kill satellites, but it's not as visually dramatic. So when you're talking to your friends about that, you know, you can tell them that. And for The Martian, Andy Weir spent a lot of effort. Andy Weir's the author. I really loved both the Martian movie, and I've started reading the book. I consider them very, very good, entertaining. The character has a good sense of humor. Andy Weir spent a lot of effort trying to make it realistic. Like, he worked out a timeline of where would he be as he moves across the surface. So at least in the book, those are real locations and a realistic timeline and stuff like that. The really big inaccuracy is sandstorms on Mars don't blow you over. The air is only less than 1% as dense on Earth, and even if the wind is twice as strong, it's not going to have hurricane force that pushes you and pushes that antenna, you know, to hit the character. I hope I'm not giving spoilers. Now sandstorms will be bad. They will leave dust on your solar panels. The tiny particles can move fast. They can abrade things, you know, so they could sand a camera lens. But they're not going to knock you over. And there's very few reasons I can think of where you'd have an emergency launch on short notice where you don't have time to retrieve a crew member. So.
I love the fact that there's 70s disco on Mars.
Oh, yes.
That's spectacular. So I actually talked with Andy about this, and he was fully aware that that's not what a Mars sandstorm would be like. There, in fact, wouldn't be a sandstorm; it would be a dust storm. But he's an author. It is science fiction. He needed a man versus nature conflict, right? And maybe he could have chosen nearby asteroid impact. Maybe that would have been somewhat realistic, more realistic. But it's also not something anybody's familiar with. But people understand a storm, a blowing sandstorm. Everybody can relate to that, not just space nerds like us, but just the general public. And so he was fully aware that he was making a stretch there. And if he hadn't done it, Hollywood would have done it for the movie, I'm sure. So it's okay. Give him a little bit of license on that one. But it's important to know that wouldn't happen. That's right.
There was actually a space conference out west. It was someplace like Albuquerque, and they had to evacuate the exhibit tent because the storm was blowing up.
So almost coincidentally, NASA put out a call for astronauts that a lot of people are saying is for their Journey to Mars map. Kind of coincided really well with the Martian release. Do you think we're ready to start training these astronauts? Do we need to put some more time into like robotic exploration or remote exploration of Mars before we're ready to even think about sending people to Mars? Or is it we have to plan so far ahead that we need people now?
I think that humans to Mars is a technically feasible thing. It's tremendously expensive at the present time. And the rate limiting step that I see for human exploration of Mars and many other destinations in the solar system is just how much it costs to get one human 100 miles above the surface of Earth. If that cost comes down, if that starts to be a more frequent routine activity, then all of those Moore's law developments in electronics, economies of scale, all sorts of things start to flow very positively after you solve the problem of the tremendous expense of getting 100 miles up. And that's why I'm very excited by these new developments of Virgin Galactic and SpaceX and companies like that that are really starting to change things.
Yeah, that's a really good point. I'll again tomorrow night I'll talk about one part of the strategy for getting people to Mars is it's been proposed that it's going to be a huge amount of money. It's going to be $100 billion. It's going to require this what John Clarkson has called an Apollo moment. The president getting up and committing the nation to put 4% of our GNP into 10 times the NASA budget. And it turns out there are ways to do that, to get to Mars in the 30s without having to do that. And I'll talk about this Planetary Society study that we did with JPL, an aerospace company, tomorrow night about that. But I'll just say one more thing relevant to this though. And we can look to history, and to get Apollo 11 to the moon in 1969 took Ranger, Surveyor, Mercury, Gemini, and Apollo 1 through 10 to do that. And so that was a decade-long program, fast track, massive impulse to the NASA budget to do that. But it took that whole precursor program, which was robotic and human working together to do that. And so the path that NASA is kind of toying with, and that those of us in Planetary Society and others want to push them into, is to get on that kind of a path. Specifically, the robotics that are happening now, Spirit, Opportunity, Curiosity, the Mars 2020 rover, the orbiters up there, Maven, other orbiters, all of them are providing information that is going to be essential, that already is essential, to planning human exploration of Mars. Future missions will carry more and more payloads and experiments that will be directly relevant to getting people onto Mars. So that's kind of like the Ranger and Surveyor programs were in the early 60s. And that effort will continue. It's a small fraction of the NASA budget compared to the Human Exploration Program, and it's great return. reconnaissance, basic information. And then we're going to need a Mercury and Gemini program, and that's what Orion and SLS can do in near Earth, in low Earth orbit. That's what the space station can help astronauts do in low Earth orbit. The lunar environment, great place to practice for Mars. Going to visit near Earth asteroids, great way to practice some of the techniques that'll be needed, just like, you know, Gemini was all about docking practice and, you know, putting vehicles together and putting infrastructure together in space. There is a path that there's a direct analogy to Apollo 11 that can allow us to have that Apollo 11 program in the 30s, and I want to push NASA down that path.
Alright, well, do you think that a lot of people seem to say that we shouldn't be going to Mars because we haven't even gone back to the moon really, and we should practice with the moon? I think you touched on it a little. Do you think it's beneficial to try and start with a station and manned exploration of the moon beyond what we did in the 60s and 70s? Or should we just start going immediately towards putting our resources into Mars, because Mars is a lot more similar to Earth, and so it would be a lot easier, and I think that we've explored it a little more than the moon because we keep sending rovers and keep sending orbiters to Mars.
The moon is just so much closer to Earth than Mars is that I think any time America develops the technical capabilities to seriously consider a Mars exploration mission with humans involved, then going and doing a lot of tremendously new things at the moon would be very, very easy if you had the technologies that you would need for Mars exploration. So I would expect a significant return to the moon before humans set foot on Mars.
Yeah, no, I agree with that. I'm not a fan of manned exploration. I'm a fan of human exploration, by the way. And I think, so personally, I think that if we can get our space agency, other space agencies in other countries, the commercial space industry we've heard about, you'll hear more about, to think about infrastructure. I know it's not glamorous, right? We don't think about roads and bridges and highways, right? And how much taxpayer money goes into roads and bridges and highways, but we use all of that infrastructure all the time, right? GPS, it's an infrastructure now. It's critical to our society. We use it all the time, even though it's not glorious to think about it. We need the same kind of infrastructure capability. That's why SLS or something like it has to happen. That's why Falcon 9 Heavy has to happen. We have to be able to get beyond low Earth orbit reliably so that we could choose to go to the moon, or choose to go to Mars, or choose to go to asteroids, or choose to fly through the rings of Saturn, whatever. And so I think that, again, it's one of these things that let's push the frontier. I'm personally delighted that NASA itself is getting out of low Earth orbit. Let's let the commercial world turn that into part of the economic sphere of our planet. I think it's a great idea because it's not the frontier anymore, right? There's some frontier research on the space station, physiological, medical, maybe some pharmaceutical stuff. Sure, that's fine. But it's not the frontier of exploration anymore. And we have to, I think NASA should be pushing it much farther beyond that. And so I'm all about infrastructure. Let's get out there.
I disagree that we should send people to the moon before sending them to Mars. There's a lot of neat stuff and reasons to do things on the moon, and a lot of them can be done robotically. I'd love to have fleets of small rovers running around the moon. They can be teleoperated from the Earth very easily, and we can do a lot of good science there and discoveries. And same for asteroids and other planets, outer planets. But I kind of cringe when people say we should go to the moon to practice going to Mars. There are some differences between the moon and Mars. There's the day-night cycle. Temperatures are more extreme on the moon. The dust is a little different because Martian dust is wind-blown. Lunar dust is not wind-blown. The water is in different places. You might get it different ways. I think we could practice for sending people to Mars here on Earth by setting up realistic environmental chambers, perhaps a very large one, or set up a rotating space station in Earth orbit, rotating for 3/8 gravity, Mars gravity. But history tells us that there are cycles of public interest or willingness to do funding, and I'd hate to set up an outpost on the moon that we have people there during the lunar daytime, 14 days at a time, and we do that for a while, and then we lose interest or we don't see a return for the money, and then there's a 20-year delay, and then we say, okay, now we're going to have a permanent settlement on the moon, and we're going to grow food there, and we find that's hard because we don't have nitrogen and carbon easily available, and sunlight and temperature problems. By the way, cooling during the day on the moon is rather difficult, and you also have to heat at night and need energy at night. So on Mars you can air cool. So I'd hate to have 2 or 3 20-year cycles of practicing on the moon, getting ready to go to Mars when it's actually simpler to grow food on Mars than it is on the moon.
I believe we have some time for audience questions if anybody is interested in asking anything. I believe we have a mic over on this side of the room, if anybody would like to get up and ask.
None of this has been controversial or anything, so it's all pretty straightforward.
So this question is for Mr. Withers. So you guys haven't mentioned radiation at all. And in my research, I study the radiation trapped in the magnetic fields around Earth. But Mars doesn't really have a magnetic field. So this could be a major problem on Mars. Do you know how we would overcome this?
No.
Oh, come on, you can't just, so it is a big deal, right? It's a big deal, because we live in a cocoon, and we evolved to live in this cocoon, protected from a lot of the harshness of space. And so, one of the things that Curiosity is doing on the surface of Mars is measuring the actual radiation environment. There's an experiment there that was funded through the Human Exploration Program to measure the actual radiation. Don't rely on models, extrapolate it, just measure it. And the good news is that it's not as extreme as had been imagined in some of the worst case scenarios. And that's good news. The good news is that because of that, sort of reasonable active measures by people who were there or on the way there in terms of shielding, using water or using Mars dirt or whatever, underground habitats, whatever, reasonable measures can be taken to lower the risk of significant radiation damage to individuals. Ultimately, people will have to sign up for a higher risk than living on the surface of the Earth. And but the models that I've seen coming out of the actual data are that those risks of cancer, for example, go up a 5 or 10% increase in risk, not 90% increase in risk. Now, long term, when people do live in these beautiful places and settle and have kids and all that, long term, that environment is going to ultimately create a different species of humans who have that just higher radiation tolerance. I think it's perfectly within the realm of evolution, based on what we know about radiation tolerant organisms on our own planet, that kind of thing would happen. So I think the news is not as dire as had been predicted previously. And is there anyone in the room who would not sign up for a 5 to 10% increase in risk to take that journey? I think people would do it.
I'll get a little more specific. On Mars, if you're standing on the surface, any radiation that is coming at you from below hits the planet. So right off, if you're on any planetary surface, you cut out 50% of your radiation compared to in orbit in a small, thin spacecraft. In addition, the atmosphere of Mars will attenuate a little bit of the radiation. So radiation that comes in from the horizon and skims through a long distance of atmosphere should get attenuated. So you can have a window facing the horizon, as far as I know. We need a little more study on that. And then if you are in one spot, namely a habitat, you can put a lot of dirt on the roof. That's very cheap to do, And it also evens out the temperature variation, so that's an advantage. And in the case of the masonry structure I showed you, that air pressure is actually held by the weight of the dirt. So you don't need tensile materials, so you get the, you don't need the tensile materials to hold the air pressure, and you get the radiation shielding as a 2-for-1 bonus. And then if you want to move around in a rover, you might want big water tanks in the roof of the rover. That will be a penalty. The hard problem is if you want to drive around in a tiny little personal rover or a spacesuit, you will get a radiation dose there.
Like Matt Damon.
Yeah. Well, then he puts his RTG inside his rover. I think that RTG did not give off a lot of radiation, but we should find an expert who knows more about it. So, and yes, people will evolve. We will learn what a reasonable dose of radiation is. Right now, NASA says there's a career limit for their astronauts, and that career limit is so low you can't go to Mars and come back. Well, is that limit realistic? Maybe in 5, 10, or 100 years we will have better ways to protect us from cancer. And also, on the trip out to Mars, you will probably have a lot of supplies in the same craft with you. You can use those for radiation shielding. The trip back is actually much more risky per day in transit, because you will have the minimum number of supplies to get you there. That'll be less radiation shielding. If something goes wrong, you won't have a lot of redundancy. An example is the Apollo 13 accident. So they were going from Earth to the moon, and they lost a lot of their oxygen and electrical power, but they had a spare spacecraft, namely the lander, that they could live in. Had that same accident happened on the return from the moon to the Earth, they would not have had the spare spacecraft. And it's the same for Mars. So a trip from Mars back to the Earth is risky, because you have fewer consumables, less equipment, and that's another reason to go there and stay.
When we're exploring the solar system, we always look for things that we need here on Earth, like water, carbon, nitrogen, which certainly makes sense in terms of human settlement of these places. But in terms of looking for other life forms, is it valid to assume that they would need the things that we need to survive here on Earth? Is there some reason other life forms couldn't survive in an environment with perchlorates and sulfates?
Yeah, so it's a great question. The search for life in our solar system and in the galaxy and the universe is sort of by definition the search for life as we know it. Because, how do you search for life as you don't know it? That's called dumb luck, right? And you can't really devise sort of a scientific hypothesis-driven approach to searching for something when you have no idea what you're really looking for, what to expect. So we search for life as we know it, meaning, based on liquid water, needing heat and energy sources, and based on organic molecules, carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. And a lot of people think about, could there be other forms of life, or a second genesis of life based on the same kinds of materials that have evolved in a completely different way? In fact, there was a conference not too many years ago called the Weird Life Conference, where a bunch of astrobiologists got together and, can we make silicon-based horta on some other world, and Star Trek nerds, you guys all get it. And the answer is, you can come up with ways, other liquids besides water and all that, but what gets you in the end is Occam's razor. The simplest way to do it is with the most abundant material that's out there. And hydrogen, the most abundant molecule in the universe, oxygen, number 3. So water is everywhere, right? And it's an easy molecule for the universe to make, and it turns out to be just a spectacular medium for life as we know it. And so when we search on Mars, when we do spectroscopy of extrasolar planets and all that kind of stuff, we're looking for signatures and signals that we would recognize. And it's not a ridiculous assumption and Mars and a planet in the Andromeda Galaxy. Doesn't matter. It's the same periodic table. It's the same physics. It's the same chemistry. You know, there could be bizarre alien physicists who've extended the periodic table out to 200 something, whatever. Okay, that's fine, but that's rare, not common kinds of chemistry and physics. So I think the answer to your question is reasonably within the realm of science as we understand it. It makes sense to look for life as we know it, and so that's what we're trying to do.
I think we only have enough time for one more question, so will you have it?
So I'd just like to hear your opinion on Elon Musk's idea of nuking the poles, and then also maybe what some more practical ideas for terraforming the planet are.
Hi. Yes, so Elon he is very enthusiastic about Mars, and yes, you could nuke the poles, but it would probably settle back to the same equilibrium again. There are proposals to spread carbon dust on the poles of Mars that would work for a while. Okay. Some people who have studied the Mars climate think that the climate might be bistable, so it can have two different stability points. In the past, it was, not too cold and wetter, and there was enough. It was warm enough that there was less ice, more water vapor in the air. The water vapor in the air trapped the sun's heat and kept it not too cold. And then something happened, maybe it lost a lot of the water out to space, and now it is very cold and very dry, and all the water is frozen. So it can be stable in either condition. Now, I'm not the expert in this, but I have been told that this is a possible climate thing. And so it may be that if we can temporarily warm Mars, we can melt the ice and then it will stay melted. Ways that you can terraform a planet, one fun way that I like is giant solar mirrors or sunshades. So for example, you could put a planet-sized sunshade for Venus in the Venus-Sun L1 position and shade the planet a little bit. Or you could have mirrors in polar orbit around Mars that are turning so as to try to provide a little extra heat to the sun. By the way, the polar caps on Mars, we've recently learned, are much larger than the white spot that's visible. There may be a fair bit of thick, frozen, icy permafrost that extends quite a ways beyond the white area. It's just covered by dust, insulating dust. So if we can warm that dust, we might be able to melt a fair bit of water. And I have a feeling you know more about this than I do.
Well, I'll just say that first, great question. Everybody's thinking about, could we live there? We're going to go. People will go there very soon. They will eventually colonize. What's it going to be like? So Mars used to be more like the Earth a long time ago, and we still don't know how or why. Paul's going to get that next year, the year after. You're going to get big answers from Maven that's going to help.
Absolutely.
And that's great. But we still don't know how Mars was like that and how it went from there to where it is today. I think we need to figure that out for our own planet, right? But yet there are still people thinking about, okay, how could we make it go back? How could we make it more like the Earth again? And one of my colleagues, Chris McKay at NASA Ames, thinks a lot about this, and he and his collaborators have pointed out a couple of things that I think are really important. It really isn't too hard, it would not be too hard to warm the Martian climate, okay? There are, CO2 is a greenhouse gas, so you need to increase the CO2 abundance, but there are actually much better greenhouse gases than CO2. Water is one of them. CFCs are great greenhouse gases, and we know how to produce them in abundance. And it's kind of ironic that we're trying to get rid of them on our own planet because we're screwing up our ozone layer, but if you were to pump them out with factories on Mars, according to Chris's calculations, you could get the atmosphere up into the very temperate range within a century. Within 100 years, it would be at least warm enough to change the nature of spacesuits. Okay? But you still wouldn't be able to breathe that atmosphere, and so then changing it into a real breathable environment it means putting oxygen in that atmosphere. It's hard to make oxygen. It wants to combine with the rock, of course, so you need to have this massive output of oxygen to get it to be breathable. And you know, it's important to recognize we are not the first species on planet Earth to screw with our climate and to cause global warming and climate change. Okay, there was a species that came before us called blue-green algae. Okay, that 2.5 billion years ago really screwed with the climate of this planet dramatically, and it took hundreds of millions of years to build up oxygen to its non-equilibrium levels. And so doing that on Mars is going to take time, right? Because it's just a much harder process to do. So you could maybe make it warm and more habitable that way in about a century's time, but you're talking about many, many centuries, tens of centuries to build up that oxygen level. Is it possible? Absolutely. It's long-term.
Is it likely we would get terraforming correct the first time that we tried, or would there be some mistakes and unintended consequences along the way? I think that's a factor to bear in mind also.
Just to give you some idea of how far terraforming might go, some people have said we might be able to get it warm enough that you could walk around in a fall weight or a light winter coat and breathe through an oxygen mask and have something on your back that separates out the oxygen from the air, and probably a face mask. That might take centuries, it might take many centuries, especially if we also can't figure out how to afford to do it deliberately. So there needs to be some profit motive, or we might do it accidentally in the process of making settlements.
All right, well, thank you all for coming to join us for this panel. Please help me in thanking our panelists for coming out and speaking with us.